Oh, by the way, before we get too far into it, remember you had those two quizzes that you had on Friday to take home and work on. Does anybody have any questions on those, or everybody have them done? Or no, you got them done? Cool. Okay, tell you what, let's make sure we have those done for Friday so you can turn those in with the test. That'll give me time to have everything graded before next Wednesday. I did a grade breakdown, by the way, and it looks like so far everybody is passing. There is one D plus, so there's somebody with some corrections to do. Mr. Berghammer has your grade, so if you're concerned about whether that's you or not, feel free to talk to him. But it looks like you guys are doing very well. I'm pretty impressed with this group this year. So let's take a peek at what we're going to talk about today. We're going to be talking about different units. Now, we've spent a lot of time with these units of length and then using volumes and areas from those. We're going to talk about units of capacity first today. And the first thing before we talk too much about these units is I want to figure out what is the difference between capacity and volume. Because there is a very, very subtle difference between them. Capacity is actually a standard container, a standard size container. Oh, she's not showing. Okay, let me. A standard container. Volume is found by measuring lengths and then combining those lengths, multiplying. For example, we've seen boxes where we had length times width times height. In fact, what we used was the area of a base times the height, but same difference. So capacity is just that standard size container. And we're going to start out with that with standard units of capacity. And we'll start out with one of our larger units, which is a gallon. A gallon actually was the size of a man's hat. Not talking about like a cowboy hat or anything like that. It was kind of European style, the derby style hat. The standard size was about 1 gallon. Now you may have heard the phrase a 10-gallon hat. Well, that didn't mean it actually held 10 gallons. It was just a bigger hat. It was an expression pretty much. Smaller than a gallon, we have quarts. Can anybody tell me how many quarts are in a gallon? 4, perfect. The word quarts comes from the word quarter, so it implies there's 4 of them in a gallon. Smaller than a quart, we have the pint. Very good. How many pints are in a quart? There are 2 pints in a quart. A pint was another standard size. A pint was actually a drinking glass. Haven't been able to find whether it came from beer or ale, but it was from one of the two. It was a standard bar glass for drinking. It was one of those units, kind of like with our inches and feet, had to be adjusted to fit together. The pints and the gallons had to be adjusted so that they would fit together. Smaller than a pint? Careful, how many cups? 2 cups. There we go. Perfect. 2 cups and a pint. A little warning, by the way. Quarts and pints, the abbreviation QT and PT, in some type fonts, a quart, a Q, and a P are mirror images of each other. So be very careful with them. It's really easy to mix those up. What is smaller than a cup? We have fluid ounces. Anybody know how many fluid ounces are in a cup? Careful. 16 in a pint. There's 8 in a cup. Smaller than a fluid ounce. We have tablespoons. Most people have memorized it, or if you have anything memorized with tablespoons, it's that there are 16 tablespoons in a cup. Well, there's 8 fluid ounces, so 16 divided by 8, there are 2 tablespoons in a fluid ounce. Bigger than a tablespoon, or smaller than a tablespoon, I should say, is teaspoon. Good. Anybody know how many teaspoons are in a tablespoon? There are 3. Now, another word of warning here. Tablespoon can be abbreviated one of 4 different ways, 3 or 4 different ways. The most common one now is just a capital T. But it can be abbreviated with a small TBSP, a capital TBSP, or just a capital TSP. Teaspoon can be abbreviated, the most modern version is just a small t, or a small TBS, or TB, just a small TSP. So you can see the abbreviations are very similar. In many cases, all that separates them is a capital or a small t. Now these next units are not ones that you'll have to know. I just threw them out here for fun. Smaller than a teaspoon contains 2 dashes. Now for a dash, think of like a salt shaker, only back in the day they had large spice shakers. So just one little, tip, one dash of the shaker was a dash. There's 2 of them in a teaspoon. A dash contained 3 pinches. A pinch was just reaching into the flour or sugar or whatever with your fingers and pinching together, and however much was there. And smaller than a pinch, 1 pinch contained 2 smidgens. A smidgen to me is kind of nasty. Basically, you stick your finger in there, and whatever stuck to your finger, you flicked into the recipe. So the cook with sweaty fingers had big smidgens, apparently. Those are units. Those are actual units. You can actually get measuring spoons for those. There are units bigger than a gallon. Does anybody know how big a bushel is? A bushel is actually 8 gallons. Now there's something smaller than a bushel. It's called a peck. The old phrase, Peter Piper picked a peck of pickled peppers. Or if you buy strawberries at a strawberry stand, they got the trays. Most of those are 2-peck trays, or some of them are 1-peck trays. A peck is 2 gallons approximately. Anybody know how big a barrel is? No. A lot of people say 55, but 55 gallons is actually a drum. 31.5 gallons in a barrel. Okay, so we've said that capacity and volume measure similar things, and there is a relationship between them. 1 gallon contains, and I should put little squiggly lines here, it's not exactly equal, but approximately equal to 231 cubic inches. Now you think about that, that sounds like a lot of cubic inches, but if you think of like a gallon milk jug, you're looking at about 6 inches by 6 inches. That's 36 inches right there. About 7 inches high would put you over 231 cubic inches. So that is about right. How about a cubic foot compared to gallons? In fact, let's think of it this way. You guys are all familiar with a 5-gallon bucket. Would you say a 5-gallon bucket, would you say that is smaller or larger than a cubic foot? Smaller? Anybody say larger? It actually is considerably smaller. 1 cubic foot is just under 7.5. It's actually about 7.48 gallons. So a 5-gallon bucket is about 2/3 of a cubic foot. Okay, so then let's take a look at our next set of units. We're going to deal with units of weight and mass. To talk about weight and mass, again, kind of like volume and capacity, I need to talk about what the difference is between them. Mass is the amount of matter in an object. This is literally how many particles, how many atoms and everything else are inside that object. How much stuff is in the object. Weight is not necessarily a property of the object. It's related to the mass, but it's the force of gravity on the object. And the way they're measured is quite different. In order to measure the force of gravity, we need to use something that would indicate with gravity or has a relationship to force. And a spring is the perfect thing. Most springs, a good spring, will stretch equally as you increase the force. So if we have an unloaded spring, let's do this. So when a spring is unloaded, it has an indicator on it with a scale on it. That's why it's called a scale. And when it's unloaded, it's not stretched, so that there's a little indicator attached to that spring that points at the 0 number on the scale. And of course, it's numbered up 1, 2, 3, 4, whatever, as that spring stretches downward with gravity. So if we now put our object on there, that scale has stretched downward and the indicator has moved. So 0 is up here, the indicator has moved down here. So the distance that indicator moves indicates how far the spring has stretched and indicates the force of gravity, the weight of that object. Mass is measured on a balance. So think of like a teeter-totter. You put the object we're trying to measure on one end, then we place known masses on the other end until it balances. And once it balances, whatever this mass is equal to the mass of the object we're trying to measure. So you might be wondering, well, that depends on gravity too. What's the difference? Well, the difference is if we go to the moon. On the moon, gravity is 1/6 of what it is on Earth. So on the moon, this would stretch about 1/6 as much. So it'd be indicating like this. So the spring isn't going to stretch as far because there's less force. So indicating a lower weight. However, on the moon here for the balance, yeah, the gravity is less, so it's going to pull on the object we're measuring less, but it's also going to pull on the known mass at with a smaller force. So the same mass is still going to balance our object. So the mass does not change. It is not dependent on gravity. Now on Earth, gravity is relatively constant. The Earth is actually oval-shaped. Gravity is slightly more at the poles and slightly less along the equator, but not a lot. I mean, let's say you take a 200-pound person. If they go from the North Pole to the equator, their weight may change by less than 2 pounds. So it's not enough that we worry about it. So on Earth, we tend to use mass and weight interchangeably. So talking about standard units still, there is a unit of mass that most of us have never heard about. It's called a slug. You ever heard the expression, you drink a whole slug of whatever, or you have a whole slug of these out in the shed or whatever? That's where it came from, as a slug is a unit of mass. One slug on Earth would have a weight of about 32 pounds. Looking at weight, we'll go from large to small again. Our large unit of weight is the ton. How big is a ton? 2,000 pounds. This is actually what is called a net or a short ton. 99.99% of the time when you hear the word ton, they are talking about a net or a short ton, which is 2,000 pounds. That implies that there is something called a gross or a long ton. And a gross or a long ton is 2,140 pounds. What's the difference? Well, if you think of going to a job, if you're working for $10 an hour and 40 hours a week, you earned $400 for the week. But you're not going to get $400. That is your gross. That's the total amount that you earn. But they're going to take out taxes and all that other junk, and they're going to give you your net, which is smaller. It's the same thing here. The ton was originally used for buying and selling grain. And a ton of grain was about 2,000 pounds. But you could not put 2,000 pounds of grain on a scale without a container. It would fall off. So the container that held a ton of grain was about 140 pounds. So the gross ton is the grain with the container. The net ton is the grain itself without anything else in it. Now you'll notice I used LB for my abbreviation for pounds. It would have made sense to use PD for pounds, but in the bookkeeping system that they used for keeping track of buying and selling grain, PD was already being used for the abbreviation for paid. So they didn't use that, and they used LB, which comes from the Latin word libra, which is the Latin word for pound. Smaller than a pound, what do we have? Ounces, good. How many ounces are in a pound? 16 ounces in a pound. Now again, ounces, they use the abbreviation from the Latin word instead of from the English. And I don't remember what the Latin word for ounce is offhand, but that's where the OZ comes from. There is a unit smaller than an ounce that many people are not familiar with. That's called a dram. A dram was one of the original apothecary units. You might be prescribed an eighth of a dram of ibuprofen or whatever. 1 ounce contains 16 drams. Now there are units smaller than a dram. Oops, I said 140 up here. It should be 240. Sorry. So anyway, that should be 2,240 for a gross ton. As I said, we're never going to use the gross ton, so you don't have to worry about that. So anyway, back to our drams and our ounces. There is a unit smaller than a dram that just doesn't get used very often. It is called a grain. Anybody who is into hunting and has maybe reloaded their own shells, you've heard of a grain. There are 7,000 grains in 1 pound. So it's considerably smaller than an ounce or a dram. There's also something, if we were in the medical field, there's something called a minim. There are 60 minims. and an ounce, but we're not going to worry about those. Kind of a side note, you won't need to know this either, but I want to bring it up. You hear on the news all the time, gold reached $1,700 an ounce or whatever. Those ounces are not the same as these ounces. We had mentioned before that every country, for feet and inches, different leaders at different times had declared that their thumb and their foot was going to be the official inch and foot of their land. Well, the same thing happened with ounces and pounds. Different countries, different regions had different leaders who declared that this unit's going to be the standard unit for everybody under their rule. So there were different inches and different feet out there, just like there's going to end up being different pounds and different ounces out there. So precious metals, like gold, silver, and even platinum, the world's center years ago for buying and selling precious metals was the island of Troy in the Mediterranean Sea. So we actually still use their units for buying and selling gold, troy measure. So a troy pound is approximately 0.82 of our US pounds. So it's considerably smaller. However, 1 troy pound only contains 12 troy ounces. So a troy ounce is actually slightly larger than a standard ounce. Now again, you'll never be tested on these, but I just wanted you to be aware that there are different units out there that get used for measuring gold and silver. Okay, so let's take a look now at metric units. We'll start out with capacity. So our metric unit of capacity is the liter, abbreviated with just an L. Now, I was always taught that it had to be abbreviated with a capital L. The reason for that was this. Is that 51 or is it 5 liters? Well, if that's a capital L, it's obvious that it's 5 liters. Back when I was in school, I graduated from high school in '91, so it's been a few years. Your typewriters and even the early computers, the type font is very tough to distinguish between a 1 and a small l. In fact, some of your really old typewriters before my time didn't even have a 1 key on it. They just used the small l for ones. So we used a capital L to make sure we knew that that was liters and not a 1. Now with some of the new modern type fonts, it's pretty clear the difference between a 1 and an L. So it is acceptable to use a small l to abbreviate it. In fact, I believe your textbook does. You'll see me always using the capital L just because that's what I'm used to. So just like with meters, going smaller than a liter, we had deciliters. So that's abbreviated with a DL. And centiliters, abbreviated with a CL. And milliliters, abbreviated with an ML. Going larger, we had deca, decaliter. We already had DL for deciliter, so they used DAL for decaliter. Hecto, which meant 100, of course. That's HL. And kilo, which is again 1,000, so that's KL for kiloliters. And yes, this is still 1/10, 1/100, 1/1000. This is still 10, 100, and 1,000. Now, just like our other units, some of these intermediate units didn't catch on. We tend to use the main unit, we tend to use milli, and we tend to use kilo. In fact, we don't even use kiloliters very often. A kiloliter is like 270 some gallons, so it's kind of large. It's a lot of fluid. There are some applications. You see deciliters used some in the medical fields. If you've ever had a blood test, who's ever had their cholesterol checked? There's a couple you maybe have, not nobody. If you get your cholesterol checked and it comes back at like a 140, they're saying that's 140 milligrams of blood glucose per deciliter of blood. Or if you have your blood sugar checked and it comes back at a 70, again, that's 70 milliliters of blood sugar per deciliter of blood. Okay, our conversions are exactly the same as they were for our links. So if we have 2,800 milliliters, I need to convert into liters, we are just moving the decimal point. So from milliliters to liters is 1, 2, 3 spots to the left. Decimal point goes 1, 2, 3 spots to the left. 2.8. For mass and weight. The unit of weight in the metric system is one we don't hear of very often. It's called a Newton. You may have heard it in a physical science class. It comes up a lot in physics. Newton is that measure of force or weight. We don't use that very often outside of sciences in the metric system. More often than not in the metric system, we use mass. And the unit for mass is a gram. A gram is approximately the mass of a large paper clip. And again, we have the same thing. We have decigrams, centigrams, and milligrams. We have decagrams, hectograms, and kilograms. And again, the main unit has caught on, kilograms has caught on, and milligrams is very useful in medication. And this one more so than many of the others. We keep going. Remember we jumped from 1,000th down to a millionth, which was the microgram, which is expressed with that Greek letter mu. Micrograms are used a lot for measuring smaller dosages of medication in the medical field. Going larger, remember kilo was 1,000 grams. We had mega, which was 1,000,000 grams. A megagram has been given a special name because the ton was so ingrained in buying and selling food and other agricultural goods throughout the world. They used a megagram to be called a metric ton. So a metric ton is 1,000,000 grams or 1,000 kilograms. There's about 2.2 pounds in a kilogram, so a metric ton is about 2,200 pounds, a little bit bigger than a standard ton. Now, of course, the conversions are going to work the same way. One of the great things about the metric system, I said it was a planned system. If we were looking at the standard system, we had 231 cubic inches in a gallon. And if we wanted to do pounds, there's just of water, there's 8 pounds per gallon. Not really good conversions. But if I look here, a milliliter is defined to be a cube that is 1 centimeter by 1 centimeter by 1 centimeter. In other words, 1 milliliter equals 1 centimeter cubed. If you're into motorcycles at all, you might hear a 1400 cc motorcycle. A 1400 cc, well, 1400 cc stands for cubic centimeter, centimeter cubed. So 1400 cc is 1400 milliliters because they're the same. Converting from milliliters to liters, you move the decimal 3 spots. That is a 1.4 liter motor. So some of your 1500 cc motorcycles literally have a motor that is as big as some of your smaller 4-cylinder or your economy 3-cylinder cars. A gram, we said, was about the size of a large paperclip, a mass of a large paperclip. The gram was defined to be the mass of 1 milliliter of water. So there's a very quick conversion between mass and capacity and length in the metric system. So because of that, let's say I have a tank. And let's say this tank is, well, let's go 2.4 meters. I know it's quite a large tank. By 1.3 meters by 0.8 meters. To find the volume, I'm going to find the area of the base down here, which is 2.4 times 1.3. I'm tired today, so we're going to punch that one in the calculator. 3.12 meters squared. So for our volume, it's that area of the base, 3.12 meters squared, times our height of 0.8 meters. So it's going to give us 2.496 meters cubed. That is our volume in meters cubed. However, if we want to convert this into milliliters, we have to have that in centimeters cubed. In fact, what I want to know is how many kilograms of water could this tank hold? So I still have to get that capacity. So I need to convert 2.496 meters cubed into centimeters cubed, because centimeters will convert to milliliters, cubic centimeters. On the chart, from meters to centimeters, it is 2 spots to the right. But now, because this is cubed, how far do we have to move the decimal point? Three times that, right? So it's going to be 6 spots. 2 spots on the chart times 3, because it's cubed, is 6 spots. So 1, 2, 3, 4, 5, 6. We've got to add zeros. So that is 2,496,000, oops, yeah, cubic centimeters. So that's a lot of cubic centimeters. How many milliliters is that going to be? Well, 1 milliliter is 1 cubic centimeter, so that'd be 2,496,000 cubic centimeters. How many grams would that be? Well, if it's water, 1 milliliter is 1 gram of water. So that's 2,496,000 grams of water. So how many kilograms would that be? Well, to get from grams to kilograms, we've got to go 3 spots to the left. So our decimal point goes 1, 2, 3. That is 2,496 kilograms of water in that tank. Any questions there? If that were a standard measured tank, it would be a lot more difficult. If we assume that 1 gallon is 8 pounds of water. If you wonder why I always underline pounds, by the way, it's the same type of thing. Because LB looks almost like a 1/6, is that 716 or is that 7 pounds? Underlining the LB makes it clear that that is pounds and not 16. So anyway, let's take a tank. Let's say our tank is 6 feet by 4 feet by 3 feet. So to find its volume, first of all, with the area of the base, which is going to be the 6 by 4, which is 24 square feet. So the volume is going to be that area of the base, 24 square feet, times the height of 3 feet. So it's going to be 72 cubic feet. To convert that into gallons, well, I'm going to have to go to our conversion factors here. 72 cubic feet over 1. We're going to put cubic feet on bottom so that it cancels out. Gallons on top. 1 cubic foot is 7.48 gallons. So 72 times 7.48, 538.56 gallons. The cubic feet canceled out, and that's over 1, so that's just 538.56 gallons. Now we still have to convert that into pounds, and we can continue to use our conversion factors. So 538.56 gallons over 1. I gave you up above that 1 gallon equals 8 pounds. We can use that just like a conversion factor. So the gallons cancel out. We're going to multiply that by 8. So it's 4,308.48 pounds. So over 2 tons. So you can see that's a very sloppy conversion. Okay, for the next part of what we want to do here, what if I were to tell you guys that I can throw a baseball at a rate of 90 feet per second? How many of you believe me? 1 or 2 of you? Is that fast? Not really? Well, if you think of a baseball field, it's 90 feet from first base to home plate. So 90 feet per second means if I were standing at first base, I could throw the ball to home plate in 1 second. Well, what are we used to seeing speed measured in? We're talking about how fast a pitcher throws the ball. You're usually talking about miles per hour, aren't we? So let's convert 90 feet per second into miles per hour. So 90 feet per second, when we put it into something to calculate with, is 90 feet over 1 second. That's the form we needed in to calculate with it. We now have to change feet into miles and seconds into hours. Let's do the feet first. So I'm going to put feet on bottom. Miles are going to go on top. The relationship there is 1 mile is 5,280 feet. The feet now cancel out, and I have miles on top, seconds on bottom. That would give me miles per second. So I have to get rid of those seconds. Do I have a direct conversion from seconds to hours? Well, we're going to go through minutes here. 1 minute is 60 seconds. So now the seconds have canceled out. We now have miles on top and seconds on bottom, which is not quite where we want to be. So we're going to get rid of minutes. We have miles per minute right now. Let's put minutes on top, and we have a conversion between hours and minutes. 1 hour is 60 minutes. So now the minutes cancel out. Now we have miles on top and hours on bottom. That's where we wanted it. So let's multiply out. 90 times 60 times 60 is, what is that, 324,000? The units up there is miles. On bottom, all we have is the 5280 times 1 times 1 times 1. 5,280 hours. So we divide that out. 324,000 divided by 5,280 is, well, like 61.36 miles per hour. Now, how many of you think I can throw that fast? I suppose on a good day I could. Every year it gets to be more difficult. I have to warm up really good, and I could probably only do it 4 or 5 times before I'd be tired. So anyway, we can make these conversions, multiple conversions at a time, by using that conversion factor. And what we had mentioned before is called dimensional analysis. You line up the units where it's going to cancel out to get to where you want it to be. Other things you might convert with this. We might have something that is listed as 3.2 pounds per square inch, or PSI. And we need to convert that into pounds per square foot. Well, 3.2 pounds per square inch is 3.2 pounds over 1 square inch. Do we need to change the pounds? Nope, we're starting with pounds on top and we're ending with pounds on top. That does not need to change. But we are going from square inches into square feet, so that has to change. Now the square inches are on bottom, so to make them cancel out, we have to put them on top. So the square inches are going to cancel out, so square feet will have to go on bottom. 1 square foot is how many square inches again? 144. You guys are getting good at that one. So yes, the square inches cancel out. 3.2 times 144 is 460.8 pounds over 1 square foot. So that's 460.8 pounds per square foot. We might have something that is given as a density of 3 ounces per cubic inch. And we want to know, what is that going to be in density? We're used to materials like wood. Most woods have a density from about 45 up to about 70 pounds per cubic foot. So is this wood? Is this in the right lane to be wood, or is it too dense or not dense enough? Well, we're going to change that into pounds per cubic foot to get a comparable density. So again, 3 ounces per cubic inch is 3 ounces over 1 cubic inch. I'll go ahead and get rid of ounces. We are changing ounces into pounds. So ounces go on bottom, so they'll cross cancel. Pounds on top. And now we know the relationship is 1 pound equals 16 ounces. So the ounces cancel out. Now we have to get rid of the cubic inches. So they're on bottom, so to cancel them out, I put cubic inches on top. And we're going from cubic inches to cubic feet. 1 cubic foot is how many cubic inches? Not 144, but perfect, 1,728. Good job. So our cubic inches cancel out. We now have pounds on top and cubic feet on bottom, which is what we want. So on top here, we're going to multiply 3 times 1 pound times 1,728 is 5,184 pounds over 1 times 16 times 1 cubic foot is 16 cubic feet. So 5,184 divided by 16 is 324 pounds per cubic foot. So that is definitely heavier than wood. That is probably close to the density of steel right there. Let's say that you have a pump. This is something that used to happen to me every now and then. You dig a house basement, and you go home for the weekend. You're going to come back on Monday and start pouring the footings to get ready to to do the foundation? Well, you have a storm over the weekend and you come back and there is water in the basement. So you hook up a pump. Yes, I know, that almost looks like a pump. That pump that you have is capable of pumping. Oh, let's see, let's put it at 2,000 gallons per hour. Is that a fast pump? Well, what I'm used to seeing pumps rated in is something called CFM. CFM is cubic feet per minute. And a good pump is anywhere from 9 to 20, well, 8 to 20 cubic feet per minute. So let's convert our 2,000 gallons per 1 hour into cubic feet per minute. So the gallons have to be canceled out. So they go on bottom to cancel out on top. Turning those into cubic feet. 1 cubic foot, 7.48 gallons. So the gallons are gone. We now have cubic feet per hour, but I want it per minute. So I put hours on top, minutes on bottom. Hours had to go on top so they would cancel. 1 hour is 60 minutes. So the hours cancel out. On top here I have 2,000 times 1 cubic foot times 1. That is 2,000 cubic feet. On bottom I have 7.48 times 60 minutes. Is 448.8 minutes. So 2,000 divided by 448.8 is, oops, I had to needed one more zero. It's actually 4.46 cubic feet per minute. So that's actually a really slow pump. 2,000 gallons per hour sounds like a lot of water. It really isn't. In fact, let's do that conversion quick. How many gallons of water could be in a basement like that? So let's say we have this basement here on a house that if you look at it from the top, the house is supposed to be 36 by 48 feet. Now that means that the hole being dug is going to have to go at least 3, 4, 5 feet around on each side. I usually try to go about 5 feet. So it's going to be about 46 by 58 feet for the hole. So that means the area of the base will be 46 by 58. Giving us 2668 square feet is the area of the base. So that's the area down here. Now let's say that foundation fills up with 3 feet of water. Your typical foundation is dug between 6 and 8 feet deep. So I mean, it could be more than that, but let's just go 3 feet of water filled it up. So we're going to take that 2,668 square feet times 3 feet of depth, which gives us 8,004 cubic feet of water. You all right there? Okay. So let's convert that into gallons. 8,004 cubic feet over 1. Put 1 cubic foot on bottom, and it's 7.48 gallons per cubic foot. So it's 8,004 times 7.48. 59,800. We're going to call it 59,870. We're going to round it. So that is just under 60,000 gallons of water in that basement. So even if it only was a foot deep, it'd still be 20,000 gallons of water in there. So that pump that we said was pumping at 2,000 gallons an hour, sounds like it's going fast. Well, it would take literally 30 hours to pump out that basement if it was 3 feet deep of water. Let's look at one of our conversions we're going to look at is we're going to look at board feet. And we'll look at this in more detail, hopefully next week, Wednesday. But 1 board foot is equal to 144 cubic inches of wood. So if we have a 2x4, and we're going to actually say that it's actually 2 inches by 4 inches. We all know it's smaller than that, but we're going to say it's actually 2x4. By 8 feet long, let's figure out the board feet. Well, 8 feet is 96 inches. So we have to do that first. The base of this, I'm going to use this rectangle right here for the base. So the area of my base is 2 inches by 4 inches, or 8 square inches. So that my volume is 8 square inches times the 96 inches of length. Gives us 768 cubic inches of volume. Using that conversion here, any two things that are equal can be used as a conversion factor. So 768 cubic inches, we put it over 1. Cubic inches on bottom. Board feet on top. 1 board foot is 144 cubic inches. So the cubic inches cancel out. 768 divided by 144 is 5 1/3 board feet. So that 8 foot 2x4 is 5 1/3 board feet. Oh, let's take a look at metric system. If we have metric units that are set up like that, let's say we are going to go 3 meters per second. Is that fast? Well, it sounds like it, doesn't it? Well, let's put that into kilometers per hour. Three meters per second is 3 meters in 1 second. And we're going to have to convert the seconds into hours and the meters into kilometers. But what I would do is this. I'm going to just convert the metric units. We can convert by moving the decimal point. So I'm going to convert the meters into kilometers. 3 meters, we move from meters to kilometers, move the decimal point 3 spots to the left. So that's 0.003 kilometers. So you can see it's a little different in the metric system. But now I still have to get rid of the seconds. So I'm going to put seconds on top, hours on bottom. I know before I went from hours or from seconds to minutes and then from minutes to hours. I'm going to cheat knowing that 1 hour is 60 times 60 or 3,600 seconds. So 0.003 times 3,600. So I use 3 there. 10.8 kilometers per hour. So that's moving pretty slow. That's about 6.5 miles per hour. What if we have something that is given as 4.2 grams per centimeter cubed. And I want to know what is that in kilograms per meter cubed. Now, since both units here are metric, got 4.2 grams over 1 centimeter cubed, we can just move the decimal point for each of them. So we're going to change the grams to kilograms. Grams to kilograms is, again, 3 spots to the left. So that becomes 0.0042 kilograms. We also have to change centimeters cubed into meters cubed. From centimeters to meters is 2 spots to the left, but because it's cubed, we have to triple that. So it's 6 spots to the left. 1, and then we have to add zeros. 2, 3, 4, 5, 6. So that is 0.000001 meter cubed. If we divide that out, this is 4,200 kilograms per meter cubed. That's a lot. You gotta think about meter cubed is pretty big though. So let's look at conversions between units. We know that 1 inch is 2.54 centimeters. We learned that one quite a while ago. We know we can add to that 1 gallon is 3.785 liters. And 1 kilogram is about 2.2 pounds. We can use those conversions to convert between different units. Let's say we are given that something is 40 pounds per square foot. We want to convert that into kilograms per square meter. Well, 40 pounds per square foot can be thought of as 40 pounds over 1 square foot. We have to get rid of pounds and convert to kilograms. 1 kilogram is 2.2 pounds. Pounds are gone. We have kilograms per square foot. Now we have to get rid of square feet and go to square meters. Well, 1 meter is how many feet? Well, 1 foot is 12 inches. Let's do this. 100 centimeters times 2.54 would be 254. Oops, I had that wrong. 100 centimeters divided by 2.54, I should say, is 39.37 inches in a meter. Divided by 12 is going to give us 3.28 feet in a meter. But this isn't feet and meters, it's square feet and square meters. So I have to square that. Well, 1 squared is still 1, so that's 1 square meter. 3.28 squared is 10.76, we're going to call it. Feet squared. So 1 square meter is 10.76 square feet. So the square feet cancel out. So what we have here on top is 40 times 1 kilogram times 10.76. Which gives us 430.4 kilograms. On bottom here, we've got 1 times 2.2 times 1 meter squared. That's 2.2 meters squared. So we just have to divide by 2.2 here, giving us 195.64 kilogram per meter squared. 40 pounds per square foot, by the way, is your typical roof load. A roof is designed to handle about 40 pounds per square foot of snow, ice, water, whatever else can be loaded on it. Okay, that's it for new material. So I do want to give you a brief little outline of, well, let me give you the homework first. It's out of the big book. Page 253 and 254. Exercise 8-9 and 8-10. Also, page 255 through 256, exercise 8-21 through 8-22. Then we're going to go to page 257, exercise, this should be 8-11 and 8-12, not 21 and 22. I got a misprint on my paperwork here. So on page 257 is exercise 8-13. That's going to be A and B. So then we'll jump up from there to page 274. On page 274 through 279, it's going to be exercise 9-11, 9-12, 9-13, 9-14, and 9-15. So that's practicing all of these different units: capacity, mass, weight, and some of the compound units. So just to kind of go over all of the stuff that we have covered in this unit here, the second half of the semester. On Friday, the test will contain all of these measurement conversions. Feet to inches, feet to centimeters and meters, but also with the area, square feet to square inches, square yards to square feet, and volume, cubic feet to cubic yards, or cubic inches to cubic feet. And with the area, make sure you remember the acres. You do get to use your books and the notes on the test. In fact, this test, you will work on it on Friday in class, and you'll get to take it home over the weekend to finish it, because I don't foresee you guys finishing it in an hour and a half in class. It's a pretty long test. That's one of the reasons why I want the quizzes done and turned into Mr. Berghammer by Friday, so that you don't have too many things at home to work on. We'll also then have to do operations with measurements. Add, subtract, multiply, and divide feet and inches, pounds and ounces, gallons and quarts. You'll actually have to measure lines. So you need to have either a tape measure or rulers to use. You'll have to calculate volume and surface area, like we spent a few weeks on that one. And that's the main thing. So you need to be able then to use some unusual shapes. We did things like that roof house, the hip roof on a house. It looks something like this. You'll be able to find the area of that roof. Or we had like the pond with a circular deck around it, finding the area of that pond. Or one of my favorites that might come up again, that's a hint, is the track. like that. Find the area of the track or the perimeter around the outside or the perimeter around the inside of the track. Any questions? Okay, so we got a little over 20 minutes left. I will give you guys the last 20 minutes to work on these homework assignments here. I know I gave you quite a few there, so go ahead and get started on that. If any questions come up, let me know. Otherwise, I will have the test to Mr. Berghammer here probably later today, so that you'll have plenty of time to get that copied. It's a few pages. And we'll have the whole day on Friday to work on the test. And like I said, you guys will get to take it home over the weekend to finish it. So make sure you have those 2 quizzes to bring in on Friday and turn in.